So welcome everyone. Welcome to the College of Design, Construction and Planning and the University of Florida.
Very glad to see this visit happen. I'm really excited for the future collaborations, and I'm glad that the team will be able to see what is the University of Florida as we kind of build out our, and Chime, we'll have a ribbon cutting April 16th for our makerspace at Howard.
Oh, awesome.
And so also one thing we're trying to do is kind of see what you have there.
Sure.
I think we're still in the relatively early phase, but we'll make sure you get an invitation just in case you want to come to DC in April. But just delighted that you all are coming together. So
thank you very much.
for hosting.
Yeah. So when rain came, you had a lot of water. And then those stairs in the middle were in little waterfall, and so very problematic. So this was one of the first things to make this safe. The roof, one of the fears was that it would create, almost make it like a greenhouse.
Yeah.
But then you see it's not fully enclosed.
Yeah.
So it actually has a convection. Yeah, the classes resume on Monday.
On Monday, yeah. So yeah, this looks good. For us, this is
So you can, that's the back of the new building, and it's kind of joined to the existing.
And it's not directly tied to the NAWIC, but it is, we do have a NAWIC chapter. But they do things that where we've had 2 events that they've had. But if you guys have any questions whatsoever, and I'll see you at lunch, please don't hesitate. I mean, we're very proud of what we've done, but we know we can always.
Sounds like a very impressive and strong program, I'll tell you.
Thank you. Thank you. I'm happy. I mean, it's one of those things. Let me grab something for you.
Okay.
And then we'll walk down and I'll show you our recent renovation to create a senior studio. And we stole the idea from Auburn. So when, like I was telling you, when 3 or 4 years ago, clunky computer lab over there. I mean, really, when I talk about clunky, it was designed for when the building opened in 2003. Okay, right? So I mean, it was the one where you had the monitors and the 35-pound PC, right?
Yeah.
And we had a PhD room here. So we took the wall out and we created this space. It is large enough for all of our seniors. And so you notice we've got a keypad. The seniors have the tables. Well, that's the wire system under the carpet. We got to feed those off the wall. Did these buildings, when we did these classrooms, we made sure there were power ports. And I want you to look at how old this is.
Yeah.
Before we had good wireless, there's your Ethernet port.
Yeah.
And so the last money we spent was about $300,000 on upgrading all the. So when we did the upgrade, we created this fishbowl. And the idea was we were going to use this for like seminars and advanced classes and stuff. That's why we use it. The students have just
They do.
They absolutely love it. It's kind of like this is our Starbucks.
Yeah, so like student lounge.
And so they commandeered it. And the one thing I was going to show you here, real quick.
We'll allow this one here.
was a really rough MEP lab. And so we didn't have proper audio visual or anything like that. And so this one, we put probably most money into because of. These always makes me think of Star Trek. Well, these are supposed to have like a 20-year supposedly, and I think these, some of our equipment are big. Yes. So I think these are 350 to 20.
I get this.
Thank you.
Business management and stuff like that. I think it's critical that they understand that.
So you have interdisciplinary, it's architecture, construction management,
Yeah.
engineering, and then business?
And business, yeah. Yeah.
So do you see capturing any business students?
We might, because I look at
Construction and planning. You guys have Dean Numba. This is Trustee David Brandon. He's one of our board of trustees, one of our 1981 construction management graduates. This is Kirsten, who's along with him today. We'll take you on a tour of the building. If you have questions, please ask along the way. This is like tour, and I'm not exaggerating, it's like tour number 96 for me on this project. So you can imagine this is a labor of love at this stage. Kind of give you the groundwork. It is an active construction site, so please keep your hard hats on at all times. A couple of quick things just for historical context about the facility and what we've done over the years. Back in 2017, I believe it was, we had a hurricane come through here, Hurricane Matthew. The dean was coming actually back from an international trip. Hurricane's coming. We have to actually lug sandbags around, block all of our doors. Our south-facing balconies were leaking. That wall, so we can do more outdoor lectures. We have a lot of guest lecture series. All of our facilities right now, dating back to 2016. This is all has to rent space for anything special we want to do if it can't happen in here. So before the atrium roof came on, we would have to rent space in either FAC, which is next door where the auditorium is, the main auditorium, the university auditorium here on campus. We were spending a lot of money on having to rent space just to do specialty events. And so now with this type of situation, people will actually want to come rent our space. So one thing I'll point out about this, the landscape plan in particular is very unique to the University of Florida. It's probably unique to the state university system in Florida. This is one of the first bioswells, natural and intentional bioswells that you'll see on campus. You'll see the two concrete cisterns right there. They're about 4 feet deep of water. So when we get a heavy rain or we get hurricane force rains, those will actually show up. As they have the robotics lab coming out, this entryway is big enough to where Dr. Aladdin Alwisi and his team can bring full-scale walls out and actually build rooms and whatnot to look at that. So he's already completed and tested wood frame walls. They're onto light gauge steel and concrete printing as well. He has plans to do actually. He's been doing currently his lab is what I would call a shack, about a mile and a quarter off of campus. He has 2 ABB robotic arms. The cool part about what he's doing is he's not using any ABB pieces of equipment other than the arms. They tested this window system for about 10 years. It was a friend of theirs. They tested it for about 10 years on their own facility. It is a zinc-based metal system where as the UV rays hit those windows, those actual systems close. And so they create a shading element. There's no motor in that. It's all based on the UV rays and a chemical reaction. When it's fully operational, it actually creates a gator skin. So of course the Florida gator, so as you walk by here, you'll see a pseudo gator skin on the windows throughout the day.
Yeah, you can just about see it on this side.
Yeah, you can if you step over this side, you can see it. So a more cost-effective. So now you're on the inside on the 3rd floor. So I'll point out a couple things as we walk through. One is When we did the student feedback, which is very critical to us, as you can imagine, you all can imagine, if you're building a facility and you own engineering and architecture or construction management, we know what we're doing. We teach it. We're designing, we're teaching our kids how to do this. So we involve the students and the faculty very early on in the process and the programming. I point out, which typically you wouldn't, but I'll point out the conference rooms that you'll see throughout. We're basically doubling the amount of conference room spaces that we have in the college, because when I have a tentative agreement with the lead singer and backup vocalist for Sister Hazel. They want to do a fundraising acoustical show in here whenever we open up the building. So we're trying to work that out with them. So kind of a cool thing that we can open up this facility. It does have blackout curtains right above us, you can see, and a screen that we're going to go in. So during the day we can do lectures, we can close it off. At night we can just put the screen down. We want people to see in. All-tooth design on the outside of the building. If you look throughout the inside of the building, it flows throughout. So even the sawtooth on this side of the paneling is intentional, as well as the way that the roof actually faces the north-facing windows to bring more natural light in. So everything was intentional there. I mentioned our materials library that was an FAC. This is now behind these walls will be our new materials library. Probably about double the size as well. It's open air intentionally. They're going to have their own little conference room table right there with the in-ground power, so they can actually work on those interior design architecture projects as they see fit. I mentioned the woods. Actually, there's more wood in here today than there was yesterday. The right side that you see is the Brandon family undergraduate space. So this space to the right is meant for our undergraduate students hot desking throughout the day. They can come in, they can plug in. And so there'll be seating here that's not a part of the hot desking, but we're trying to utilize every space and every panel we can to make more for crits and pinups and whatnot. And so you'll see all the pinup walls over there, and then this is another digital pinup almost, if you will, for students who have their models.
Main campus proper, 2,000 acres, a little over 900 buildings. Founded in 1853. Never, not one time before this building has 50% of the capital been raised privately. Wow. These guys did that.
Good job, thank you.
First time ever.
It's a very good job, thank you.
With a lot of help today.
Well, we did. We had a lot of help from a lot of our donors and our alumni, and they all rallied around an idea that was probably talked about in the industry a lot, of why don't we get along better.
Almost starts here. If you can see here at the corner, you may see the metal sheets, because we reached to the point where we have to manufacture our own components. 3D printing, you see, I have 3 of them. This is one of the obsolete ones, because after the print certain time I have to actually... Exactly.
Do your own thing.
The whole 9 yards. So this actually contains currently 6 patents, 5 hardwares and 1 software. So the 5 patents start with the first one. The first patent introduced the concept of how two industrial robotic arms can work together, achieve the multifunctionality needed to actually frame a full wall in one station. Think about it as one factory station. So we had the first patent. If I show you the first 2, they were much simpler than this, but we had to move forward. And then thanks to Autodesk, thanks to NSF, we got extra fund and we expanded from a small station to this, I would call it patent number 3, because patent number 2 was automating the design and manufacturing. So from a BIM, or building formation model, we were able to automatically generate all of the manufacturing strategies through ROS and Robot Studio that need to be accomplished in these 2 robots. So that was patent 3, and we were actually lucky enough to receive the UF Innovation Award for our
Historically, I've been here 10 years, so this has largely been a materials lab since I've been here. Done a little bit of structural work, did some geotechnical work. We built a full-scale wall right here on an MSE wall that we tested a few years ago. But we shifted a little bit. Now, for the foreseeable future, this will be our 3D printing space. So we've got concrete 3D printer right there, and we're going to be doing trial prints. And then I'm working now on going over to larger prints over by the end of this year, and then we have plans to go really on campus. All of our materials are made here on site. There's our stockpiles there. We've only done a few prints at this point. We're getting ready to really ramp that up. We had some issues with the electrical, so we got to hardwire it. We're running everything off of that generator, but we had some diesel fumes issues because we're down here in the pit. They call it the pit. We're getting diesel fumes that we're getting pulled into the office.
Yep.
Yeah, so now we have to hardwire into that, but we're still going to be able to run everything remotely when we want to do prints off-site.
Can I look at your aggregate size that you use in this?
This is a number 87 limestone.
And this runs in the 3D printer?
Number 89 limestone. So the 89, an 89 stone is nominal size 3/8 of an inch.
Yeah, 3/8.
That we can do. What is it? What's the max size on that? Like 16 millimeters, 17 millimeters, I think.
It's about a ½ inch.
Yeah, a little more than a ½ inch is what you can do, just based on your pipe diameter, really.
Right.
Oh, yeah. We definitely, a lot of practice is needed. Dialing in. There's a whole materials team and there's a print team.
It's amazing that you guys can. I have to film myself doing this. This is amazing, concrete 3D printer. Oh, okay, nice.
Year, the races change every single year. So they take this, and this will go out to the lake next week, and then they'll practice with it leading up to the competition. So that one that they're going to make on Saturday won't touch the water until the competition day. This is the practice one. So if you don't want to risk breaking it, so this in theory should handle very similar to the one that they actually make on Saturday. This is our material right here. This is our welding layout table.
You have millers. Okay. Nice.
So this is a laser welder.
Okay.
This is a very nice laser welder that we're not going to use this year.